Sometimes, the biggest breakthrough in science isn't a discovery. It's a question. A question so important that it forces everyone to stop and look again. A newly published peer-reviewed paper in Frontiers in Veterinary Science isn't claiming to have proved Librela causes reported adverse events. Instead, it asks something potentially even more important. What if there is a biological mechanism that could explain at least some of the reports? If that mechanism exists, it could fundamentally change how researchers investigate these cases. Tonight, I'm examining one of the most important veterinary publications of 2026 and why it has immediately become part of the ongoing debate surrounding anti-NGF therapy, a different kind of paper. Unlike the Mike Farrell paper published in 2025, this is not another pharmacovigilance study. It isn't another analysis of adverse event reports. It isn't a clinical trial. Instead, this paper asks a completely different question. Could there be an underlying biological explanation linking some of the reported adverse events? That distinction matters, because before you can prove a mechanism, you first have to propose one. That is exactly what this paper attempts to do. Understanding NGF. Librela works by targeting a molecule called nerve growth factor, or NGF. Most people know NGF because of its role in pain, but NGF does much more than transmit pain signals. It also helps maintain and support certain nerve cells throughout the body. The authors argue that reducing NGF activity may involve more than pain control alone. Their central idea is something they call neurotrophic withdrawal. The hypothesis, according to the authors, if NGF provides ongoing support to vulnerable nerve cells, then blocking NGF could, in some circumstances, reduce that support. The paper proposes that this reduction might help explain why some reported adverse events appear to involve several body systems rather than only the joints. The authors discuss musculoskeletal events alongside urinary, autonomic, and, more tentatively, neurological events as areas where this hypothesis could be investigated further. Importantly, they present this as a testable scientific hypothesis, not as proof that this process occurs in treated dogs. Why this matters? Scientific progress often begins with a hypothesis, years before diseases are understood. Someone asks the right question. This paper attempts to provide a biological framework that researchers can now examine experimentally. If future studies support the hypothesis, our understanding could change. If they do not, the hypothesis will need to be revised or rejected. That is how science advances. The author's perspective. The authors suggest that older dogs with multiple health conditions may be particularly vulnerable if the proposed mechanism is correct. They also argue that additional independent research should be undertaken before widespread routine use is assumed to be appropriate. These are the author's interpretations and recommendations based on their review and hypothesis, and they remain subjects for further scientific investigation. What happens next? One paper rarely settles a scientific debate. Instead, it changes the questions researchers ask next. This publication will likely encourage more laboratory studies, clinical investigations, and continued pharmacovigilance to examine whether the proposed mechanism can be demonstrated in practice, whether the hypothesis is ultimately supported, refined, or rejected. It has become part of the evolving scientific discussion around anti-NGF therapy. Science is rarely a single moment. It's a process, a hypothesis, a challenge, a test, a replication. This New Frontiers paper doesn't claim to have the final answer. It proposes a mechanism that can now be explored. Where the evidence leads from here will depend on the research that follows.